look at that on a on our particular example. So here we've said that a publisher is not a particularly good publisher, but physically at some state of its life it might be in a position where it's not yet publishing any books. So we'll put a 0 to many multiplicity on book, on the association between the publisher and the book. For sure, a customer may not yet have purchased a book, but they might be registered as a customer, and a customer might a specific book might have many customers. So what we can have here is a situation where a specific book could have been bought by, if it's a very bad book, no customers, or it could have been bought by a large number of customers. We don't want to put a boundary on that. So again, 0 to many customers on the association between book and customer. On the other end of that particular association, R3, then a customer at any one time could have purchased a book, or they could have purchased a number of books in a particular transaction. But what we're saying there is that they're not actually being a useful customer unless they purchase at least one book in a transaction. So we're not going to take any we're not going to actually represent them as customer until they've actually purchased a book. You can talk through the other associations there yourselves. They're fairly clear. There's a little bit more we can do with this now. Once we've got the basic representation there, there's some things we need to think about. So what happens next? Well, I said a customer is a customer if they've bought a book, but they could be buying more than one book. Where do we put the information about the number of books that the customer has purchased? It doesn't really belong in a customer, because the customer could be involved in some other transaction at a later date where they will be buying a different number of books. And in fact, the number of books they're purchasing is a somewhat transient activity, because once they've completed that purchase and the purchase has been delivered, then that relationship between a particular book and the customer can be dissolved. It's a transient thing. So there's something missing. It's indicating that there is an entity in this diagram which is missing, conceptual entity. And talking a little bit about that, you'll come to the analysing a little bit more detail. At a very simple level, we can introduce one additional class, which is that of an order. That's something which goes between the customer and the order. It's capturing the relationship, the transient relationship between a customer and some book products. So I've pushed that in there. So now we've got an orders associated with one customer in this particular model. You might refine that a little bit for some other kinds of commerce transactions. But in this case, an order is made by one customer, and it is tied to a customer, so the order has to have a customer associated with it. So there's no conditionality on that. It's an unconditional relationship. And similarly, a customer makes an order, and that order can contain the purchase of a number of book products. So we've refined that model a little. So that's given some basics of class modeling. What I want to do now is to go into a little bit more about building good class models. So that's a simple, very first process which we've taken of identifying nouns, put those nouns down onto a piece of paper, draw some boxes around them, add some attributes or properties that we want to capture in our model, we think are important in our model, and the elements of abstraction are in terms of identifying what are the important properties and ignoring the irrelevant properties. We've drawn some associations between those. Those associations have helped us identify the responsibilities of those classes. And now we want to talk a little bit about how to refine those models a bit. There are a number of things which I'll do. I want to talk about in this lecture just one particular aspect because I've mentioned it several times, and then in another lecture we'll go into some more detail about refining models. So, specifications versus things. This is a key thing, and it's sort of lurking in the background of that model that I've shown you already. I've mentioned it a little bit, but what I'll do here is use a different example just to show the variety of object modeling, and we'll use this concept of an aircraft. I mentioned specification versus things in cars versus a car specification. Let's look at an aircraft versus an aircraft specification. This is essentially database normalization. So if we look at the aircraft, then it will have a number of properties. It'll have a registration number, it'll have a maintenance status associated with that, and that might be triggering some state behavior in the aircraft. At any one time it might have an assigned pilot, an assigned mechanic. It'll certainly have a number of hours flown. Now that aircraft might be of a particular type, and that type will have some features of itself. It'll have a fuel consumption, it'll have a wingspan, it'll have a weight, it might have a particular stall profile, some information which is important for the pilot or the flight control system. We don't put that information into the aircraft class. Why don't we do that? Because there are going to be a large number of instances of the aircraft with different registration numbers, with different maintenance statuses, but which have all the same value for model number, stall profile, weight, and so forth. So a simple database normalization analog is to factor that out into a separate class. It's important to do that. The aircraft specification and the aircraft have different life histories, they have different numbers of instances, and you are doing what all Rails programmers should be doing, which is not to repeat yourself. Factor out that common information into a separate class. So there are going to be 0 to many instances of an aircraft which is designed and specified by a particular aircraft specification. So that's representing those multiplicities associated with air. So the aircraft specification in itself is an abstraction. It's the properties common to a specific aircraft type. The aircraft itself is a concrete class, and it represents the properties that are common to a specific aircraft instance. So all of the aircraft instances have to have a registration number, they have to have a maintenance status, they have to have an assigned pilot, and they will have an association to a specific aircraft specification, but only one aircraft specification. And as I said, each of those two classes have very distinct life cycles and properties. So an aircraft will have a complex state behavior associated with it. One aspect of that is the cycle through its flying, landing, taxiing, docked, taxiing, takeoff, and flying again cycle. Another aspect of that life cycle, which can be triggered at any time when it's on the ground, is to move it into a maintenance phase, and that'll trigger a different route in its life cycle. The aircraft specification generally will have a very simple life cycle, and you might not even want to associate a state machine with the specification. It's usually used as a reference document, and that's all. At some stage it might be that that aircraft specification is no longer maintained because there are no more instances of the aircraft type that are flying, although the timescales over which that happens are typically very large. And as I mentioned, there will be a small number of instances of that aircraft specification. It might go through some versions, but they will be normally small numbers, and in fact different types will be regarded as different aircraft specifications normally. That's at that point I'll stop at this point, because I've covered the main things I want to cover in this introductory lecture to modelling with classes and building domain models with classes. So there's quite a lot to reflect on there. It is very basic stuff, but it is important to get those clear in your mind, because building a model in Ruby on Rails or any of the other web applications isn't about just collecting a bucket load of objects and managing those as classes. There needs to be some design rationale there. There needs to be some very clear association with conceptual entities that are meaningful in your domain of application, and it's thinking deeply about that that makes the difference between a good application and a less adequate to an inadequate application. So this is really important material. In a follow-up lecture I'll go into a lot more detail about critiquing your domain models and give you some tools, some conceptual tools about how to do that.